So looking up at the very top, just the definition of absolute value. I'm not going to highlight part of it because I would just end up highlighting all of it. So make sure you know what absolute value is. It's written as the absolute value of x. Those are the two little bars on either side of x there. It represents the distance between x and 0 on a number line. All right, distance is the best example of absolute value. Okay, and it's like I said, it's taking the distance. If I'm standing right here, okay, just because that wall, let's say, is 10 feet from me, that doesn't mean that wall is negative 10 feet from me. Okay, it's positive whichever way you go, which is kind of explained a little bit here also by that number line. Whether you're going right or left, you're talking about a positive distance going there. Okay, so going to the table, which you should already have filled in. All right, go filling this part out. What is the absolute value of negative 4? 4. Negative 2? 0? 2? 4. Awesome. You need to memorize these because here in a minute, whenever we do an equation, graph an equation that has multiple transformations, we're going to go off of those numbers. It's kind of similar to what we did last class with the move the monster thing. What is the domain of that graph? Alvin? Negative infinity to positive infinity. Meredith, what is the range? Okay, what do I need to make sure to have on there? A bracket on the 0. On the increasing, decreasing part, that's just talking about which part of the graph is increasing. So I've got the red line over it right there. It's kind of hard to see. There you go. And you're writing the domain for that part of the graph that has a positive slope. Which, David, what would that be? 0 to infinity. And then Jeremiah, the decreasing is the part that is not in red, or the part that has a negative slope. So what would that one be?
Negative infinity to 0.
On the positive, this is just asking, essentially all that's asking is what part of the graph is above the x-axis. Okay, so Avery, what would? Do what? Okay, not 0 to infinity, because that just means that this part is above the x-axis. But if all of it is above the x-axis, then what would I need to put here? Jake, helps out.
Always positive.
Okay. You could put always positive. You could put all real numbers, negative, positive, and whatever is saying that it's all of it is above the x-axis. Right? Remember, we have a few graphs that have part of it below the x-axis. So that's where that would come into play. In behavior, as x approaches positive infinity, y approaches what? Infinity. As x approaches negative infinity, y approaches what? Infinity. Do I need to re-explain in behavior? Because moving forward, that's probably going to be just as important as domain and range. Going over to the right, what is the axis of symmetry for this graph? Okay, it's the y-axis, but what is the equation for that line? Daniel? Yes. Nope. Just the red line, the straight red line I have up there on the graph. What's that, David? X equals 0. Guys, underneath axis of symmetry, I want you to put x equals the x value of the vertex. Your axis of symmetry, it's always going to be that. So if you know the vertex, you know the axis of symmetry. All right, Helene, what would the vertex be on this graph? 0, 0. All right, your x and y intercept, it's going through the origin, so that's all three of those just happen to be the same thing. And Gavin, would this be considered a maximum or a minimum graph? Minimum. So make sure you can identify all that. If you want to star the parts that are important, or the most important, I would say, it's those right there. Domain, range, and behavior, axis of symmetry, vertex. If I had to add one more, I'd maybe say max or min. But that's not too difficult. Okay, so let's go through these transformations. Your d value, which two directions does the d value move the graph? Up or down? And is that with the sign or opposite the sign? With the sign. Plus is going to go up, minus is going to go down. Next, let's go to the front, talk about the a value. Is the a value, is this going to be the vertical stretch and compress or the horizontal? Vertical. And if a is greater than 1, is that stretch or compress? Stretch. If a is between 0 and 1, that is going to be your compress. And then if a is negative, which axis does it reflect across? X-axis. Feel free to use this little shorthand notation. That's just my sign of reflect across. Alright, so both the d value and the a value. Greta, are those going to affect our x values or our y values? The y values, because it's going up and down and it's a vertical stretch or compress. So let's go inside the absolute value bars. The C, does it move it to the left or to the, or sorry, it moves it to the left and the right. And is it with or opposite the sign? Opposite. Plus is going to go to the left. Minus is going to go to the right. Your B value. So if A is vertical, obviously this one is going to be horizontal. If the B is greater than 1, is that stretch or compress? Somebody tell me. Compress. Remember, this is the one where you've got to take the reciprocal of the actual number, and you'll use that. Between 0 and 1, that is going to stretch. And if the B value is negative, that's going to reflect across what? Y-axis. Talked to you last class. These are probably the most common kind of questions you're going to see on an assessment. Here's an equation, list the transformations. Or here's some transformations, write the equation. All right, so Helene, looking at 1A, give me one of the transformations that's happening in there. Is 2/3 greater than 1 or between 0 and 1? Yeah, between 0 and 1. So vertically compressed. Make sure you put by what number. You'll see why here in a little bit. Jacob, what's another transformation in that equation?
To the left 3.
Left 3. Greta, what's the last one? So the -4 at the very end. Down 4. Feel free to use shorthand. By shorthand, I mean arrows and VC instead of vertically compressed. I meant to mention this too, and Jacob got it correct. But whenever you're looking at the C value, a lot of times it will not have parentheses. Okay, like A and B. If there is a B value, like in C, then it will have parentheses. But the C value is always inside with X. Looking at the next one, Meredith, give us one of the transformations. Okay. Gavin, give us another one.
To the right.
I don't know. Dalton, give us another one.
Up 9.
Up 9. Caleb, what does the 3 do at the front?
Down 3.
Do what?
It's a vertical stretch.
Okay, vertical stretch. Okay. Kiana, give us one of the transformations on C. Not right 2. So you're looking at the B value. If +3 is the C value, which direction? Let's do the +3 part. +3 is going to move it which direction? Left 3. Rachel, what's another transformation?
It's reflected across the y-axis.
Awesome. Jake, the last one. And be careful with this.
At, I don't know.
David?
It's vertically.
Nope.
Oh.
It's inside, Jeremiah. What's it going to be? Okay. So it's a B value that's greater than 1, so it's horizontally compressed by what number? 1/2. Good. Because that's the one you got to take the reciprocal of. Okay. Remember, reciprocal is just that number flipped. You've got to do your best not to see that number as -2. You've got to see it as a negative. The negative does something. The 2 does something else. Okay? Let's go to A. Don't write. You can write g of x if you want here. Don't write anything else that I write up here until we're done with the whole equation. So if I call on you, I want you to tell me to replace a letter with a certain number. Okay? So if it reflects across the x-axis, it's translated right 3 and down 2. Alessandra, give me a number to replace a letter with. Okay, for the A, the C, or the D?
C.
For the C. Good. Gavin, give me another one. Plus or minus? If it goes, yep, okay. And Jacob Wilson, what's the last one? So we've got right 3, we've got down 2. Okay. So the A needs to be replaced with a negative. If you put -1, it's still correct. That's fine. All right, so going to B. Alvin, if it is reflected across the y-axis and horizontally stretched by 2, what would that equation look like?
It'd be a negative B value.
Okay, and what would that B value be?
1/2.
1/2. So you've got the absolute value of -1/2 x. Oop, not parentheses. All right, let's go on to the graphs. We're just going to jump to number 4. Okay, so on that one, Jeremiah, what's the transformation?
It goes right to
Number 4.
the left 4.
Okay. Greta, what's another one? So it goes what? Which direction? Down 2. And Meredith, what does the negative do? Okay. All right, so let's look at this. Whenever we graph this, kind of off to the side, I want you to write this. To find your vertex, it is going to be, and I put -c because it's always opposite the sign, comma D. That's always going to be your vertex. Okay, so if I have 4, but in the equation it's +4, the x value is going to be -4, and then the y value is -2. If I follow my transformations, that's where that takes you. I don't care if it's reflected, vertically stretched, compressed, horizontally, whatever. -c, comma D, that is going to be your vertex. So on this one it would be -4, -2. Now, your A value, you can treat your A value like you would a slope. All right, linear and absolute value, those are the only 2 functions where we're going to deal with the slope. So if my A value is -1, if I'm treating this like the slope, am I going to go from that vertex? Am I going to go up 1, right 1, or down 1, left 1? If it's -1. Down 1, left 1. Okay, or if you want to speed up the process, down 2, sorry, not left, but right. Alright, so you have that part of the graph. Then you would go back to the vertex, and then you would go down 1, left 1. So Jeremiah, is this a max or a min? Max. On my domain, is every absolute value graph going to have that domain? Yes or no?
Yes.
Yes. Every one of them. So come quiz time on Thursday, if I hand you something and it asks for domain and range on a graph, you don't even have to look at the equation for the domain. That's it, every time. All right, the range. David, what would the range be on this?
Okay.
switch those.
Okay, from negative infinity to -2.
Yes. And that was one common mistake I saw a lot on the quiz, y'all's quizzes last class. Guys, the lowest value should always be first. So you will never put negative infinity in that spot right there. You will never have positive infinity in the first spot. Ever. Alright? And I said it at the beginning of the notes. Your line of symmetry is always x equals what? It's what, Gavin?
0.
Nope. It was for the parent function. But I said that your your line of symmetry is x equals.
-4.
Okay. So it's the x value of your vertex, which on this one is -4. Alright, let's go to the back. Or the next page, whatever it is. Okay, so this is where I was, at the beginning I was saying you need to remember those points for the parent function. And this is when that's going to come into play. So, again, looking at the transformations up there. Meredith, give me a transformation. Okay. Gavin, give me another one. That's with the sign. Up 2. And Jake, what's the last one? The 3 at the front.
Vertically stretched.
Okay. So looking at the table below, what you want to do on the left side of the table, I am going to put the x values of the parent function. -4, -2, 0, 2, 4. On the right side, I'm going to put the y values, 4, 2, 0, 2, 4. So first, let's look at the x values. So I've got right 1, which is a horizontal transformation. What do I need to do to all of my x values? Add 1. So I'm going to take all of my x values. Now I can just put that little part at the top of the table next to the x. So I'll take each one of those x values and I'm just going to add 1 to them. And Kiana, if I'm moving the whole graph up 2, what do I need to do to all the y values? I need to add 2. And then Alvin, if I'm also vertically stretching it by 3, what do I need to do?
Multiply
So the multiplying by 3 is your vertical stretch. Your adding 2 is your up 2. And then you just plug in those original y values. 3 times 4 is 12. Plus 2 is 14. 3 times 2 is 6. Plus 2 is 8. 3 times 0 is 0. Plus 2 is 2. And you've already figured out the bottom 2. They're 8 and 14. And now you can go through and graph the points that you figured out. Okay, I will tell you this. If that change, that 0 plus 1 is 1. And 4 plus 1 is 5. Sorry, it's a Monday. Alright, so you're going to go through and graph these points. I've got -1, 8, 1, 2, and I've got 3, 8. Okay, now I know doing it this way, this probably took a little bit longer than it did on the front. But whenever you have an equation that has multiple transformations, this is especially a vertical stretch and a vertical compress, I would most definitely do it this way. Also, if you're pre-cal bound, that's kind of the method they use right there. So going down to the bottom, Kiana, what was the vertex, or what is the vertex? One, two. Greta, is this a maximum or a minimum? Minimum. Meredith, what is the range? The range, not the minimum. Make sure you get the domain in there. I'm not going to ask anybody what that is from here on because it's always going to be the same. And Helene, what is the axis of symmetry? Do what? Not the x-axis. Alessandra? X equals 1. It's whatever the x value of your vertex is. Go to the next one. I'm going to do the same thing. I'm going to write those values to the left and to the right of my table so I know what to input. Dalton, what's one of the transformations on this one? Daniel, what's the other one? So you got a B value that's between 0 and 1. By what number? By just 2. So if it is a horizontal stretch, is that going to affect my x's or my y's? X's, so I'm going to multiply all my x's by 2. If it's going down 3, what am I going to do to all my y's? So let's go down and look at these next few. The only difference here is they're giving us the graph and they want the equation as opposed to the equation in the graph. I would fill out all of the information below first. Okay, so Alvin, what would the vertex be on this first graph? 0, 1. Okay, my domain is always the same. Avery, is this a maximum or minimum? Rachel, what would the range be? 1 to infinity. And David, the axis of symmetry.
X equals C.
Okay, so I can go in. I know it didn't reflect. The V is up, so that tells me I got a positive A value. If it's going up, remember that's how you're going to check your A value. It's kind of like you're checking your slope, rise over run. It's 1 over 1, so I don't have an A value. I'm going to use the red lines for the absolute value bars. It didn't go left or right at all. And then it went up 1. So I've got plus 1 at the end. So that's that equation. So going to the next one. Kiana, what is the vertex for that graph? 1, 1. Jacob, is it a max or a min? Maximum. My domain is what it's been for every problem we've done. Jacob Wilson, what's the range?
The range is
What always needs to be first?
-1.
Negative infinity to 1. Always bottom to top. And then, Meredith, what's the axis symmetry? So I'll come up, I'll write my equation. So on this, Alessandra, does my A need to be negative? Yes. Is it reflected across the x-axis? I can check my slope for my A value. Okay, it's 1 by 1 again. Gavin, what does my C value need to be? Negative what? Look at the screen, Gavin. There you go. Okay. Remember your C value and the X value of your vertex. Okay? That's how you find it, negative CD. So now, Gavin, what would the D value be? Plus or minus? There you go.